Hello everyone, I'm Namrita, a PMR scholar at IIT ISM Dhanbad. So this is problem solving session for the course Differential Equation for Engineering, in which we will discuss the problem related to the week session 10. Am I audible?
Yes, ma'am.
Okay. Uh, so these are the questions which we will discuss in this session. The question related to the boundary, like someone asked in previous session, when x is from some fixed a to b, then what kind of solution we can get. So these are the questions which we will discuss in this session. I have already give some idea in last session how to solve these type of problem. Can anyone tell me how to solve?
By using that two conditions, ma'am, boundary conditions and initial conditions, so U of xt and Cn.
Okay, okay. In the last session, I have already give some idea about method of variation of separation, variable separable method. So we will solve with the help of variable separable method when x is bounded, like from some fixed a to b. So these type of problem we will solve with variable separable method. In the last lecture, which we will discuss when x belongs to R, otherwise positive real number. But in this lecture, we will solve the problem when x is from some fixed, means x is bounded. Okay. Okay, let's start question number one. Initial boundary value problem. The given initial conditions are ux comma 0 is sine q pi x upon L, and ut of x comma 0 is 0. These are when x is from 0 to L, and the boundary condition. Okay, so this is the question. Now, for these type of problem, uh, when the um, when x is bounded, then we will use the solution from variable separable method. For this, we will let is a function of x of x into t of some t function. Of course, this is not equals to 0. Then now we will put the utt uxx in equation number 1. Let's say this is equation 1a, this is 1b, this is 1c. So can we write x of x t dot t minus c square? When we partially differentiate with respect to x, then we will get c square x double dash x into t of t is equals to 0. Fine. Now can we rewrite the above expression as some constant? Okay. Now from here we can solve for x and for t separately. So can we write it as c square t of t is equals to 0. So we have to solve these two equations. The boundary condition will become, when we use the boundary condition, given boundary condition are 0 comma t is equals to 0 and ul comma t is 0, and we have considered uxt as x of x into t of t. From here, if you use these boundary condition, then you will get x of 0 and x of l is equals to 0. Fine. Is there any doubt till now?
No, ma'am.
Okay. Now we have to solve so this is a regular Sturm Liouville system. Real constant. Can anyone tell me what is the solution for this eigenvalue, eigenfunction? Because we have already solved these type of problem in which we have already find out the eigenvalue and corresponding eigenfunction. Please solve and tell me the eigenvalue and eigenfunction for this system. In previous lecture, we have discussed Sturm Liouville problem, in which we have already find out the eigenvalues and corresponding eigenfunctions. simply you have to find the solution and apply lambda condition, then you will get the non-trivial solution.
Ma'am, the eigen in pi by
Can you repeat? The eigenvalues are
n pi
n pi.
pi l
Okay, n pi l.
n pi divided by l.
Okay. Uh,
Is it correct, ma'am?
no, this is the eigenvalues are minus n pi upon l whole square. When lambda is negative, then we will take n square or some m square, then we will find the value of m is minus m pi. Okay, let me write. You can solve easily from here. Uh, in the case of lambda 0 and lambda greater than 0, you will find the trivial solution. Okay, so we will discuss for lambda less than 0. Let lambda is equals to some minus m square. Okay, then m is plus minus iota m. So x is c1 cos of mx plus c2 sin of mx. Okay, and when you apply boundary condition, then you will get c1 0. Fine. And when you apply the second boundary condition, then you will get the value of okay, I'm writing for n. So these are the eigen function. To the eigenvalues. Eigenvalues are minus n pi upon l whole square. Fine. N is from 1 to and so on. So these are the eigenfunction and corresponding eigenvalues and the corresponding eigenfunction or vice versa. Now, can we use these lambda n and we can find the value of t. Now, for lambda n, the general solution for I am putting the value of lambda n. From here, you can solve for Tn. What will be the solution for TL? Is it fine? The solution for TL? By auxiliary equation, you can find the root and you can write the solution for TL. Okay. So can we write for u x comma t? So this will become u n x comma t for xn and for tn. What are the solution? Uh, okay, let me write tn first. Tn pi of t upon L plus bn sin cn pi t upon L into sin, okay, sin n pi x upon L. Fine. By the principle of superposition, ux comma t is summation u n x comma t, where n is from 1 to infinity. Then the solution becomes an cos of cn pi upon L into t plus b of n sin cn pi upon L into t whole into just give me 1 minute. हेलो। यार व्हाट्सएप पे कुछ कुछ नोटिफिकेशन आ रहा है यहाँ स्क्रीन पे मेरे, तो वो कर दें, इसमें से लॉग आउट कर दें लैपटॉप से। हाँ बार बार हटा रही हूँ, आ जा रहा है कुछ ना कुछ। हम्म, ओके, so the solution is into sine of what was sine n pi x upon L. Fine. So this is the solution. Now We have to find the value of an and bn with the help of given initial condition. So the given initial condition are, now apply initial condition. First one is ux comma 0 is sine q pi x upon L, which implies if we put t is equals to 0 in above solution in this equation, let's say this is equation number 2. Okay, when you put t is equals to 0, what will get? Here ux comma 0 is sine q pi x upon L, and in the right hand side at t is equals to 0, this term will give 1 and this will become 0. So from right hand side and multiply with sine and pi x upon L. Fine. So our target is to find the value of an and bn. Okay. From here, how to find the value of an? With the help of Fourier coefficient. We have already evaluate the value of constant. How to evaluate? The integral of this into this upon, okay, let me write, integral is from 0 to L fine. You can calculate the integration. The integration for denominator is 2 by L by 2. So we can write 2 by L into 0 to L. So this is an. Now we have to calculate this integration, or we can do one more thing. Without solving integration, we can find the value of an. So from series uh, sine q, with the help of this series, we can find the solution of for an. Okay, can we expand the right hand side and we can compare? We can make this in the form of sine of x, and we can compare. We can calculate the value of an. Upon L plus a3 sine of 3 pi x upon L plus and so on. And the left hand side we can write as what is the formula for sine q of x? We know sine 3 of x, 3 sine x minus 4 sine q of x. With the help of this formula, we can write 3 sine pi x of L minus sine 3 pi x by L. Fine? Is it clear? Now tell me the value of A1, A2, A3. Here n is 1. So when you put left hand side uh, this expression and compare with right hand side, then you will get an is 3 by 4. Fine? And a2 will be 0 and a3 will be minus 1 by 4. Can we write? And an after 3 term will become 0. That means 4 or 4 to greater than 4. Now we will use the second initial condition and we can find the value of Bn. Okay. What was the condition? Ut x comma 0 is 0. So we have to differentiate equation number 2 partially with respect to t, and after differentiating we have to put t is equals to 0. So the differentiation of this will give sine of this term. So sine of this will 0, and differentiation of second term will give cos of coefficient uh, c and pi by l into t. So this will become 0 and this will give. Are you getting my point? Hello? If there is any doubt, you can ask. I think there is no doubt. So can we write after differentiating partially with respect to t and applying the condition, means putting the value t is equals to 0, then we will get cn pi by l bn sin n pi x upon l. Fine. So from here we can say bn is 0 for all n is equals greater than equals to 1. So the required solution, an is 3 by 4 cos of c pi t upon l for n is equals to 1 into sine of pi x upon l minus for n is equals to 2, a2 is 0. So we can ignore the term a2 and for n is equals to 3, the value of a3 is 1 by 4 minus 1 by 4 into cos of 3c pi t upon L for all x from 0 to L and t greater than equals to 0. So this is the required solution. Now tell me if there is any doubt in question number 1. You can ask. Yes.
Method.
Hello.
Instead of separation of variables, can we have any alternate method to solve this type of equations?
Uh, this is general method. Alternate method is just one thing is you have to learn the formula for this u of x comma t and directly you can put the value of using initial and boundary condition you can solve a and bn.
Okay.
Is there any other doubt in question 1? Okay, let me give a quick review for question 1, what we have done. So, in this question, we have to find the solution for this wave equation in which x is bounded. And we have provided the initial condition and boundary condition. So, we can use the variable separable method, means we consider the xt as a variable separable solution and we can find the solution for x and t separately, and with the help of principle of superposition we can write uxt. So firstly we will solve for x, which is a Sturm Liouville system. We already know the how to solve the Sturm Liouville system. So after solving the for x, we can use lambda and we can solve for t, so that we can write our solution in the form of un. So the solution become u of xt, which given in equation 2. And after applying initial condition, we can find the value of an and bn. With one initial condition, you can find the value of an, and after applying second initial condition, you can find the value of bn, and you can put the value of an bn. So the required solution is obtained. Okay, let's move to the next question. Question number 2. Question is find the solution of initial boundary value problem the initial condition are ux comma 0 in two parts. They provided the initial condition in two parts. When x is from 0 to L by 2 and when x is from L by 2 to some L, then you L minus x. And the boundary condition, one more initial condition is 0 when x is from 0 to L. And the boundary condition, so the question is similar to question number 1. but the change is in the initial condition. Here we have provided the initial condition in two parts. When x is from L by 2, then initial condition x comma 0 is x, and when x is from L by 2 to L, the initial condition is L minus x. So how to solve this problem? The boundary condition is similar to the question number 1. Fine. So can we write the solution? Can we write the equation 2 directly from equation 1? Question 1. Because the boundary condition is similar, when you apply the boundary condition, then you will get the same expression as we have done in question number 1. But in the examination, you have to solve from starting. You have to take the variable separable form, and you have to solve one by one step. From problem 1, the function ux comma t satisfying the given boundary condition can be obtained as can we write directly from equation 2 of question 1, because the boundary condition are similar and the problem is of course similar, only the difference in initial condition. And by x by L 1 to infinity. Fine. Now what we have to do, we have to find the value of a and bn using initial condition. Okay. First initial conditions is ux comma 0 is x when x is from 0 to L by 2, and L minus x when L by 2 to x. So after putting t is equals to 0, you will get the expression. Now what will be the value of an? Two by L, because in denominator the expression of integration from 0 to L sine and pi upon L x, sine square and pi upon L x is L by 2. So I am writing 2 by L for denominator, and for numerator 0 to L by 2, the function is x into sine and pi upon L x dx, plus when x is from L by 2 to L, the value of function is L minus x into sine and pi upon L into x. Fine. Dx. So you have to evaluate this integration. Please try to find. You can integrate by parts, integration by parts you can use. So you can integrate when you leave this is first function, second function, then after integrating the second function you will get x into cos of minus cos of n pi upon L into x into in denominator you will get pi n pi by L. When you can write in numerator as L upon n pi. So this will first term, and the second term will become, you can check the integration. The limit is from 0 to L by 2. Fine. So this is the integration for the first term, and the integration for second term, leave the first term, and the integration for second term is cos of n pi upon L into x. So this is the whole multiplication. L by 2 to L plus L upon pi n. You can check the integration by yourself. Fine. So this is the integration for second term. Now after putting the upper limit and lower limit, after putting the value of upper and lower limit, you will get this expression. So this is plus, this is minus, so we can cancel out. We can cancel out these term also. So n pi becomes 0, and the sum of these two terms with multiplication you will get sine n pi by 2. Fine. minus minus will become plus. Okay. So an will become 0 when n is even. Fine. Because sine pi by 2, when n is even, like 2, then it will become pi, 2 pi, 4 pi, and the value of sine n pi is 0. And 4l n square pi square sine n pi by 2 when n is odd. You can write the value of sine n pi by 2 also. The second boundary condition, sorry, initial condition, not boundary. U of t x comma 0 is 0. So you have to again differentiate partially with respect to t and put the value of t is equals to 0. Then you will get bn sine n pi upon l into x is equals to 0. From here the value of bn is 0. Fine. This implies bn 0 for all n 1, 2 and so on. So bn is 0 and an is, when n is even, the value of an is 0, and n is odd, the value of an is given by this expression. So the solution becomes, therefore the required solution for problem 2 is ux comma t an, which is we can write l into 2 upon n pi whole square sine n pi upon l into, sorry, this is n pi upon 2, value of an, this is the value of an, n pi into t into sine n pi, fine, where n is odd. Is there any doubt in question 2? Hello, is it clear?
No, ma'am. Yes, ma'am.
Okay, ma'am.
Okay. Okay, let's move to the next question. Question 3. Find the solution of the initial boundary value problem. Again the same, the value of expression is not same here. The at the place of c square here the 9 is given. So question number 3, I think. Okay. 0 to 20 and t is greater than 0, and the initial condition are, first one is given in the part.
Ma'am, it is 9UXX.
Okay, yes, it is 9uxx. Thank you. So this is initial condition, and one more initial condition is x into boundary condition is given. Can you use previous expression and you can put the value of c, l, and you can find the solution, because there is no difference in initial condition, boundary condition, just the value of l. Here we have provided 20, and at the place of c we have provided 9, c square at 9, and utx comma 0 is x 20 minus x. Can anyone tell me the value of ux comma t in this case by using previous two questions? After applying boundary condition, you have to just put the value of l is equals to 20, then you can get the expression. By problem 2, but in the examination you have to solve. You cannot start from here. You have to solve uxt firstly, then you have to apply a boundary condition. Ux comma t is given as summation an cos of c and pi upon l. So at the place of c we have 3 and pi upon l. At the place of l we have 20. Fine. plus bn sine 3 pi 3n pi 3n pi upon 20 into t and into sine n pi upon 20 into x. Fine, where the value of x is from 0 to 20 and t is greater than is equals to 0. Now, in similar manner, as we have calculated the value of an, because at the place of L just we are provided 20. So can we write an directly from here? Hello? Because the initial condition, first initial condition are same, just the difference is at the place of L we have provided L is equals to 20. So can we put L is equals to 20 in this expression?
Yes, ma'am.
Okay. An is obtained as 0 when n is even and 4L. L is 20 upon n pi square into sine n pi by 2 when n is odd. Fine. Now we have to calculate the value of Bn with the help of second boundary condition. The second initial condition. This is second initial condition. So with the help of second initial condition, we can find the value of Bn. How to find? Just differentiate the expression and put the value of t is equals to 0. Then left hand side is x20 minus x and right hand side will give by second initial condition, which is given as x, sorry, yes, x20 minus x. This is second initial condition, whereas x is from 0 to 20. So the expression becomes x20 minus x is equals to, after putting differentiating and putting t is equals to 0, you will get cn pi upon L bn sin n pi upon L into x. Fine. Now how to find the value of bn? X is from 0 to 20. So the value of bn is, with the help of Fourier coefficient, 0 to 20 upon 0 to 20 sine square n pi upon 20 into x dx, and this will give, sorry, this is not L, this is 20 Fine. And this is 3. So we have one more term. Not okay. So this will give the value of Bn. The integration of denominator, what will be the value of denominator? N by L, I think. Uh, L by 2. L by 2. Okay. 3n pi into 2 by L, 2 by 20. Fine. And the integration for first numerator term, you can integrate by part. Consider first term and second term into cos uh, 20 by 2, 20 by pi into cos of n pi upon 20 into x. This will minus from 0 to 20, and the second term will give, you can check the integration. I have done, so I am writing cos of n pi 20 into x from 0 to 20. Fine. So after solving the above expression, when you put 20, this will become 0, and 0, it will also give 0. And the first expression, when you put 20, it will become 0. When you put x is equals to 0, this expression becomes 0. So only we will left with this third term, and after multiplication with the coefficient, you will get, so at the place of 0, cos 0 is 1, and cos n pi is minus 1 की power n. Fine. From here, can you say Bn is 0 when n is 2, 4, 6 and so on? So we have obtained the value of An and the value of Bn. Now, is there any doubt in evaluating the value of Bn? Is it clear? Simply you have to integrate by parts, and you have to put the upper limit, lower limit, then you can get the value of Bn. So therefore the required solution for the given problem will become an. So an is 420 upon n pi whole square into sine n pi by 2 when n is odd, plus, okay, the one multiplication with 3 pi by 3 n pi upon 20 into t, plus the value of bn when n is odd. When you put n is equals to odd values, then you will get here the expression will become 2. Yani, when we multiply with 4 into 2, this will give 8, 20, power 3, 3 n pi by n pi whole power 4 into, okay, into sine 3 n pi into 20 up into t upon 20 into sine n pi x upon 20, where x is from 0 to 20 and t is greater than 0. So this is the solution for question third. Is there any doubt?
No, ma'am.
Okay. Okay, let's move to the next question. There are two questions more, question 4 and question 5. In question 4, okay, let me write the question 4 first. Initial conditions given as and the boundary condition. Here the boundary condition is given as ux 0 comma t and ux pi comma t. So again you have to use separation of variable. You have to set up for a Sturm-Liouville system for the variables and find the eigenvalues and eigenfunction. Then you can write the, after applying the boundary condition, you can write the expression for uxt. So the expression become SL problem or SL system for variable x. Find eigenvalues. These are the steps. And eigenfunction. The function is given by only the difference will occur. Here the value of c is 3. So I am writing 3 at the place of c. And at the place of L, here the given is the value of L is pi. So 3 n pi upon t upon L. So n pi upon pi into t. Pi will cancel out. Bn sine. Here also 3 and t pi cancel out. And the difference will become here at the place of sine. When you apply the boundary condition, in this case, you will get cos, the expression for cos 3n pi x upon L. So not 3 n pi x upon L, n pi x upon L, where L is pi. So we will get nx. Are you getting how to find the expression for uxt? In the similar manner which we have done in question 1 and question 1, you have to just put the boundary condition which provided the partial differentiation with respect to x. When you differentiate, this expression was given in sine and pi x so upon L, so this become cos and pi x upon L. Fine. You have to use separation of variable and you have to set the SL system for x, from where you can find the eigenvalues, eigenfunction, and using eigenvalue you can find the expression for t, and after combining and using boundary condition, then you will get the expression. Fine. Is there any doubt in this expression? While applying boundary condition in this case, you will get like this. Fine. The only difference you will get. And from here where you will get the lambda is in equation in question 1 we have obtained the value of lambda was n pi upon L whole square. In this case you will get 2n minus 1 . So the expression will give in the term of cos. You can check. Fine. Okay, I'm so now we have to find the value of a and b n again. How to find? By applying initial condition. Okay. initial condition ux comma 0 is 0 when x is from 0 to pi. Okay, after applying this initial condition, you will get an cos of nx is equals to 0. That implies an is 0 for all n. And the second initial condition utx comma 0 is 1 plus cos of q of x, which implies 1 plus cos q of x. When you differentiate with respect to t and substitute t is equals to 0, you will get 3n bn cos of nx 1 to infinity. Fine. So what will be the value of bn? Integration from 0 to L means pi, 1 plus cos of f of x into cos of nx dx upon cos square nx dx, and here 1 upon 3n. So after integration, this will give 2 upon 3 and pi. The denominator will give pi by 2, and the numerator, so the integration of cos of nx is sin nx, and after putting pi and 0 you will get 0, and cos qx can be written as 1 by 4 cos of 3 of x into cos of nx. Simultaneously I am multiplying with cos of nx, and 3 cos of x into cos of nx dx. Okay, now you have to integrate. You can write by using 2 cos a cos b formula. So cos a plus b plus cos a minus b, and you can integrate them. So after integration, I am going to write the expression plus this is integration first term, and the integration for second term will give and the limit is from 0 to pi. Fine. From here, uh, when you put pi and 0, the expression becomes 0, only except for b when b is equals to 1 and 2. Fine. Because at 1, then sign this will give, okay, for n is equals to 1 and 3, bn is 0. You can check this. for n greater than 3 and at n is equals to 2, and for n is equals to 1, the value of b1 you can directly evaluate with the help of integration also. You can put n is equals to 1 cos of x plus 3 cos q of x dx. Okay, after integration you will get 1 upon 6 pi, and this will give 3 pi by 2. You can check. So 1 by 4. And similarly for n is equals to 3 you will get these are the simple integration you can solve by yourself. After integration you will get pi by 2. So this will become, so only we got the value of b1 and b3 and rest of the bn is 0. So the expression become 1 by 4 for b1 cos of x into sine 3t for n is equals to 1, and 1 upon 36 for 3 b3 and cos of 3 of x into sine of 9 of t. This is required solution for x is from 0 to pi and t is greater than 0. Fine. In objective question you can use directly formula, but in subjective you have to solve by using the variable separable method, and for x and for t, and after combining you can obtain the solution for uxt for the system. Fine.
Okay, ma'am.
Okay, let's move to the question 5. Find the solution of initial boundary value problem. The initial condition are, this is 0 and this is 1 plus cos qx, similar to the previous one in problem 4, and boundary condition is the only difference is here. In previous condition the boundary condition is fixed for both end. Here this is free end but this is fixed end. Okay, and initial condition are similar to the question 4. The only difference in boundary condition for the one end, other end is similar. Fine. Can anyone tell me the solution for this expression uxt by using previous expression? You can guess the solution. In this question, you will get the boundary condition and another boundary condition. Both will derivative, but in this expression, after simplifying, you will get the boundary condition like this. Fine. Okay, let me write the solution, then you can see the difference. Again, use separation of variable and then set up SL system for x. Find eigenfunction and eigenvalues corresponding. Then you will get the expression after applying the boundary which satisfy the boundary condition. Here the lambda, difference in lambda. Okay. And Bn sine 3 10 minus 1 upon 2 into L into sine 2n minus 1 upon 2 into x. Fine. So this will be the solution for this expression. You can solve by variable separable and SL system for x. You will get the eigenvalues like 2n minus 1 upon 2 whole square. Okay. Is there any doubt? Anyone? Hello?
No, ma'am.
Okay. Again, we can apply initial condition. We can find a and bn and we can obtain the complete solution. Now, initial condition 1, which is ux comma 0 is 0. This will give an sine so from here an will give 0 for all n. Okay. In the second condition, which is um, utx comma 0 is 1 plus cos q of x. Then you will get, after applying this initial condition, you will get, sorry, this is 1 plus cos of q of x, and the right hand side will give bn into, after differentiating with respect to t and applying t is equals to 0, you will get the right hand side. Again, the value of bn will give the integration 0 to pi sine 2n minus 1 upon 2 into x, 1 plus cos of q of x dx, and the denominator will give pi by 2, so it will become 2 upon pi, and this term 1 upon, so 2 upon 3 2n minus 1. Fine. So you can use integration by parts. I'm going to write the expression after integration. After integration, you will get 4 3 pi 2n minus 1. The first expression 2 2n minus 1 plus, you can check the integration. This is just integration by parts. And putting the upper and lower limit. So this is the integration. An is 0 and the bn is given by this expression. Therefore, the solution becomes bn sine 3 2n minus 1 upon 2 into t into sine 2n minus 1 upon 2 into x. Sorry, this is x. Where n is from 1 to infinity and the bounds of x is 0 to pi and t is greater than 0. Let's say this is 1. Fine. So this is the solution. Okay, is there any doubt in this question? Because this is the simple integration, you can integrate. I'm not going to spend more time on the integration, and you can solve the expression for uxt as we have done in question 1. Just the difference is, when you apply the boundary condition, you have to first differentiate with respect to x, and then you will apply the boundary condition. Then you will get the eigenvalue, something like that, 2n minus 1 upon 2 whole square. So after putting the eigenvalues, the expression for xn and the tn, you will get this expression. Are you getting this expression? You can check the solution, or you can solve by yourself by using separation of variable. Fine. Please tell me if there is any doubt.
No, ma'am.
Okay. Okay, you can ask your doubt, because that is all from my side for today. If there is no doubt, then we can leave. Okay, let me discuss some questions.
Hello, ma'am.
Yes,
Uh, One question is there. Uh,
yes,
Find the solution of the initial boundary value problem utt minus c square uxx is equal to 0
yes.
um, with the
With the initial
in-
condition.
condition is u of x0 is x into 1 minus x
Okay,
and ut of x comma 0 is also x into 1 minus x.
okay,
The interval of x is 0 to 1.
x is from 0 to 1.
1 and initial condition u of 0 t is 0 and u of 1 t is 0.
You mean boundary condition.
Yeah, yes, ma'am. Boundary condition.
So, what is the problem in this question? You have to simply apply the initial condition after obtaining the expression of uxt, where you face the problem you are facing.
So here, both u of x comma 0 and ut of
I think
is,
there is some typo in this expression.
yeah. So that's why I'm having a doubt.
Okay, okay. So in this initial condition, maybe one of the expression should be something else or zero, maybe.
Okay. Um, because this question is given as an assignment.
Okay, okay. Uh, okay, I will check for this expression.
Okay,
Uh,
madam.
if I got the answer, I will send to you.
Okay, madam.
But I feel this expression should be something else. Right?
Yeah, yeah. Either it is uh, u of x or ut of x0.
Yes,
Of
because
the equation is 0.
initial condition cannot be same after moving at time t.
Yeah.
Yes. Okay, I will check this question.
Okay, madam.
Okay.
Hello, ma'am.
Yes.
Ma'am, in assignment 9, which we already submitted,
Okay.
can you explain the last question? It is very helpful to me.
What was your last question? Can you see the assignment first?
Can I share the assignment question, ma'am?
Yes, you can share. Question number 9. You are saying question number 9. Hello?
Only 5 questions are given, ma'am.
The last question of assignment 9.
Okay, last question.
Okay.
Please show me the last question. Question number 5. Question number 6, I think. Question 6.
Yeah. So this is assignment 9, question number 6, ma'am.
Okay. Is anyone who have solved this problem? Avish, have you tried this problem?
Yes, ma'am. I have tried.
Okay, you can tell me the approach.
One minute. Okay, how you have solved this problem? We first find the displacement using given data. Choose one end of the string as the origin, okay, and the other end is point A on the positive x-axis. So OL is 1 and B and C OL. Okay, this is OL is 1. OA is L. Okay, and B and C be the points of trisection of OA. Okay, OB is L by 3, OC. Okay, can you explain what you have done? Because I haven't solved this problem, so I have to look for the.
Madam, it is a trisection problem.
Yes,
Uh, so first of all, we have, by using the given data, we have constructed the region.
yes. As we can see, he's constructed the reason by given the data.
Yes.
The data is the trisection of OA is B and C.
Yeah.
Okay. The equation of line we are using
Yes, ma'am.
slope, which is h upon L upon 3. Okay.
Yes.
After this slope, you can get the expression of fx.
Again, we have to considering the EA, the line EA,
Okay. Equation
and
of the line EA.
then one more. So then function f of x is equal to over the line 0 to L by 3 and L by 3 to 2L by 3 and 2L by 3 to L.
Okay.
So this is the equation of the lines we are getting.
Since one string is released from rest, okay, this will become the initial condition speed. Nice. Expression for Bn.
Yes, directly we have considered the expression y of xt and bn and substituted, ma'am.
Okay, now you can solve
Yeah.
from here. So, are you getting this expression? Uh, who one asked, Sukhendu? Are you getting this solution?
Ma'am, in the second part, which it says that the midpoint is always at rest.
The midpoint, where you have used the midpoint as at rest?
Please, ma'am, explain this part.
Second part. Abish, can you explain the second part? Whatever he asked.
So first of all, we have to find the equation of the line between the 3 points, no, ma'am.
Yes.
So second means I think L by 3 to 2L by 3, this one, 3h by L of L minus 2x. This expression we will be getting.
Okay, just for L is equals to 0, x from 0 to L by 3, you will get fx
Yes.
from is this expression.
So first we have to obtain the expression with the line OD. So this is
Okay.
OD. So 3h by L of x.
Yes, this is fx for 0 to L by 3 and
Yes.
from L by 3 to
2L by
2L
3.
by 3 means
Yeah.
DE, the expression for
DE.
DE.
Yes. Yes, ma'am. DE.
So you are calculating the equation of line passing through 2 points
Yes, ma'am.
using, okay,
Yes. Then after EA.
equation for EA. Okay,
EA. Last one.
then you will get for L by 3 to 2L by 3. Okay,
12 by 3. Yeah. So we will be getting 3h by L of x minus L. 12 by 3 to L. That is
yes,
the expression.
fine. Are you clear, Sukhindu?
Ma'am, in the last question, the last part says that it is to be shown that the midpoint is all.
What he is saying, the voice is
Ma'am,
breaking actually.
please see the last question.
Shukhindu, we have told
not to discuss your assignment problem. So I haven't provided your assignment problem. I can't see the assignment problem. The question is, he is showing the question and he is showing the solution as well. Just wait.